Does it work? Oh yes, it does work very, very well. So good. Setting up this stuff is always a problem. So, welcome. I'm happy to see quite a few people here. I was worried that maybe because of the time no one will come, but and the topic is, I don't know. I don't know what you expect to see now. So maybe you expect from last year to show me very painful, very hardcore stuff that you don't understand, or you anyway. So I will talk a bit about our plans for the next meter-object protocol and how we do lookups for properties and methods, but I will keep it a bit general because there's so much to say about it. I think I could fill a whole track, a whole day only talking about these things, and you can go in endless details if you want. So I will go for the breadth approach or for the depth one. Yeah, I go a bit for the breadth one to allow you to get an overview and an idea of why we want to change and the direction we want to go. The exact details we don't know yet ourselves. We are talking about this a long time already, but it's only forming step by step, and you have to actually do one step, and then you start seeing, oh, that's the next step. And then, oh yeah, that's the next step. It's like going in fog, you know. You don't see where you go. You only see a few meters ahead. And then you hope you go in the right direction. If you didn't go, you have to go back and try again. But we're prepared for that. Of course, it's the task of our users to tell us when we are completely wrong. That's very important. We cannot foresee every use case. And even if we try really our best, but it depends on how you use the language and how I use the language, or how Yom or Cedric use the language. It might be totally different than what you think is typical Groovy. So, and we discussed it really since 2005, 2006, 2007. We even before Groovy 1 was released, we started thinking that some things should be a bit different than we do it, and then we didn't do it because we were afraid of breaking compatibility back then. That was before 1.0 already. The other problem with the changes there was that we didn't ever see the solution that seems to be appropriate for all needs, and was partially that is very much due to the limitations the JVM gives, partially due to you don't know what will come in the future, and so you want something that is extensible and does not limit yourself to a very narrow set of possibilities. What we absolutely have to do in Groovy 3 and will do is throw out a lot of old code. We will try to throw out as much as possible till someone of you cries and say, I used that. And then we will discuss about if you put it back in or if there's an alternative and if there really should be a change. Then, so it's really good if you try early as soon as there's something available. And the question is, why change at all? I mean, you can, of course, with the upcoming of cars, you could, of course, use your car to use your horse. I mean, let it pull the horse and drive on it. There's no problem. You can do that. Of course, it's much better to drive in the car and not keep the horse. And it's a bit like that. We had the carriage in the past with Groovy 1, and then we started developing parts more and more and more. The language develops, some backends they develops, and the horse in front, our MOP, that should be the design for Groovy, stays the old horse and gets older and older and gets wrinkles, and so you have to think about, is what we built then still appropriate to what we have now? Groovy now is not the Groovy it was at Groovy 1. If you look at what we implemented since then and how the usage changed, it's really a gradual evolution into something different a bit. And we have to think about how to meet the current needs. So the current MOP, in theory, it's a very powerful one. You can do a lot of things. I mean, you can exchange the meta class itself to influence directly the selection of methods and properties. How much more powerful can you get? Only problem is that the API of the meta class is a total devastating experience and has lots of method where you will not in a very short time learn about how they work or why they are there. It is always something you have to keep in mind. The meta class originally was planned as internal thing. So the problem was it became a Groovy line thing and kind of public, and it was never the original intention of that. It happened. That's one of the changes where we have to react to. And of course, there's the behavior is not really specified. If you had a behavior, you know, that is very specified, you could say, oh, we make this and this change, and then it's according to the spec. If your code broke, then because there was a bug. But since we don't have a spec, you have users that use bugs and say it's a feature, and you cannot argue with them because it's unspecified. You can only say, okay, this is obviously wrong, so this is really a bug. And then you have, most of the cases, you have not this case, most of the cases it's something, yeah, maybe you could do it like that, but you know, I think it's wrong, but only because I think it's wrong, it's not something that I can go and just change it. I have no right to do that, even if I'm implementing most of the stuff, because I have the user base and I have to hear what the user says. And if the user says, I use that bug as feature, well then I have to live with it even if I don't like it at all. There are a few additions that got into Groovy that I don't like at all, but I still love the language, you know. So have to hear to the people to see what they think. So to understand some parts of the talk, only a very, very short part of a bit of some basics in the history. Normally in a meta class system you have something that says every class has a meta class. That's not really the case in Groovy, but I come to that later. For Groovy we save in there all the methods dynamically added or statically available in there, the properties and the fields and all that stuff. So we can do our method selection, for example, solely through the meta class. One problem that we identified early but never could get rid of is using exceptions for control flow. For example, in your method missing, or in better to say in your get property and set property and invoke method, maybe causing to continue the selection instead of just returning what your method would return, for example. But the original design was that you invoke your methods through the meta class itself. It was never thought for doing something like quasi caching, like we did in 1.6, I think, or for invoke dynamic, which also does quasi caching, but with support from the JVM. It was never intended to be used like that. Instead, in early Groovy, you just had your invoke method, your get and set property, where invoke method had well, dubious role in that, in the way it was used. But basically, we found very early the need for being able to customize the behavior further, and so we started with the still internal meta classes, but you could set them now officially. You could always set them, but now officially. And then we added some mechanisms that these meta classes are looked up by class name, there's a special package name, and with an extension um, which was a bit. I always didn't find any need for that. Okay, but well, I know people use that. I don't know if people still use that, but I know in the past it was used. And then later was a bit more comfortable meta class creation handle, which resides somewhere in the registry. And expanded meta class, for example, makes use of that. The handle just says, if I want to create a new meta class, I can tell you what it is, what meta class is. So more or less, it produces the instance for you. Instead of the standard meta class, you can easily set an alternative one. Of course, only one. And in Groovy, as I mentioned before, instead of every class has an instance, we have more currently the philosophy of every instance has a meta class, which is, well, meta instance, or I don't know, meta class, meta of instance of class, I don't know how I should call it. Originally, it was only that Groovy objects had them, and I think originally it was not even them. It changed at some point, and I couldn't identify at what point that was. Somehow slipped my attention, or it was before me, I don't know. Later, and with later, I think it was 1.5, we added a way to have, for instance, meta classes for Java classes too. Because for Groovy classes, we save it in a field in the instance. Java classes we can obviously not change, so we have to do a bit different, which is some kind of global memory aware concurrent map thing. And the problem with all these meta classes per instance and all that is a bit, it can get difficult to understand when they are actually what. Just to see that I made this little program here, which has 2 pages, to try to explain a bit the problem with per instance meta classes. Probably some have faced that already. Some per default do expanded meta class enable globally to avoid such problems. I think it's okay. It's advised at some at several points. But the problem is that if you in my example program here, you start with a custom meta class and it's stored in my meta class. And we start with our registry having this normal standard meta class. So I create a new X and it's stored in X1, and then I verify, yes, the meta class from X1, which is the one from the registry, the original one, is not my custom one. That's only to assert to show you it didn't exist before. And line 3, I change it. I changed the X1 meta class, the per instance meta class for X1, to my custom one. Then I create a new X2, and of course this new X2, this new X in X2, it has still the old default standard meta class that was in the registry, because I changed it only for X1, for the instance X1. Then you see the line with x.meta class equals to meta class. Now I set in the registry the default meta class to my custom meta class. That means now that if I create an x3 with a new x, that this x3 will have the new custom meta class by default. I had it before in x1, I have it also as my meta class, but the x2 has still the old one, so you get an unequal here. Now let's assume I reset it to the original one, and the question is, this phantom here, the variable I call phantom, which also has a new x, which is created at a point where the meta class got the custom one, the registry got the custom one as initial meta class, and where I ask for the property of meta class after I reset the registry meta class to the original one, Now, what meta class do I have here? Does someone want to guess? Who says it's the original meta class, the standard meta class? Hands up, please. No one? Oh, I shocked the people. I see faces. They look away from the laptop and what? There's code. Oh wait. Oh my God. What is that? So I would say, depending on when you used to work with Groovy, you will either say it's the original one or you will say the new one. The actual correct answer would be it's unspecified. The practical answer is it is the custom one when the new was executed, but it's unspecified because it's the first user that decides, and only the creation of that class, the execution of the constructor, doesn't mean necessarily that the meta class is used. It may be used or maybe not used, so it could be very well be that asking here for the meta class is the first use. Well, that's what you get when you have unspecified behavior. Why do we have now by default different meta classes? And the answer more or less is that the original meta class implementation doesn't support changes. The idea was you initialize it with all the stuff, and then you kind of seal it, and then no change can be done anymore, which allows for certain optimizations, which I will not mention now, but I hope you believe me. Expanding meta class, on the other hand, is extending meta class implementation, and through some very wacky hack, causes it to be getting in a non-initialized state later, so you can add methods to then get in the initialized state later. It works, kind of. Most of the time, for most people it works. It doesn't always work. But the problem is that the behavior in the expanded meta class is not always the one we get from our meta class implementation. Just only some months ago, we fixed some bugs related to closure calls, where one way was wrapping, the other way was not wrapping the arguments in some certain cases, and that was because there was a bug that was fixed in meta class implementation, but not in the duplicated code of expanded meta class, which is duplicated, only slightly different, but logically duplicated. We have another meta class, which is closure meta class, which is normally used. There the bug doesn't exist at all. So, well, that's the problem from unspecified behavior again. But we also have many more meta classes. We have proxy meta class for some intercepting stuff. It's used for mocking, for example. We have a mixing meta class, which is only meta class by name. It's not an actual meta class, but it uses own meta class and handle meta class, and it uses delegating meta class to bring all the power of broken mixings to you. Then, as I said, there's closure meta class, which applies only to generated closures, meaning if you write in your code some closure block, that is will by default get a closure meta class as meta class, which has some short paths for certain calls in there to improve performance if the call goes through the meta class. But as always, you can have your own meta classes. So any assumption I make about how the meta class behaves to maybe speed up my code a bit or do something, they are all off as soon as there is some custom meta class involved. And the problems are, of course, not stopping there. I mean, it's nice to have a DSL for adding methods and properties, and we absolutely want to have a DSL and a nice DSL. But if you have some problems like here, I mean, I define a property bar by assigning through the meta class a value, but if that value is a closure, then it's not a property, then it's a method. well, it's kind of convenient, but what do you do if you want closure as value for your property? Well, then you have to create some dummy with null, and then you set it later with the assignment. Well, that's only for the instance. Okay, then you have to go through to the meta class, ask it for the meta property, and then set there's something that probably no one knows, which is some initial value creator thing, where you can set a closure that sets the value that is initially used for the property when you ask. Then you can have that, which is not nice. That's something where we have to work, absolutely. And with adding methods, it's not always working correctly. So in this example here, I have a class A. I have a method 2, it returns just a string 2, and I have a method doIt, it calls 2, and adds done. So if you call doIt, you expect 2 done as return, and that works nicely, of course. You can add methods there and all, no problem. But now we extend the class with a class B, and then suddenly problems start to come. We said we want to override our original 2 method, and it should say my new 2. We create our instance of B, and we call b.2. And it says my new 2. Yes, it works. Then we say b.doIt, and it says 2 done. It should have said my new 2 done. Now it says 2 done. Why? Don't ask me, I don't know. I really don't know. It's somewhere extremely deep in the internals of how the meta class is organizing the stuff internally, and this is largely unmanageable code, which means we of course have to do a rewrite here. But as I said, if you have unspecified behavior, and even if you do only internal changes, you will cause breaking changes to other people because you change the unspecified behavior. You don't have a chance to keep the unspecified behavior because it's unspecified. A is expecting something different than B, and then you have the problem. There's a trick to make this case work, by the way, which is making A implement truly interceptable, which is even more mystery why it works, because that should really not have any influence at all, but it works. I know this causes internally to do the method invocation a slightly different path, but, well, okay. I guess I would have to spend several hours on finding why this happens exactly. I didn't try, I have to say here. How about we just add a support method? Not override one, just add one. So I have a modified version from before, and now I don't have a 2 method. I only have a method missing to catch the missing method, of course, and it only returns the 2, so it can send in for the 2 call. Yeah, and as you see, that works. So I can add some methods to the subclass. But if you look closely, I changed the meta class of A here, and I work on B. Now, I mean, we have per instance meta classes and all, and I changed here the general meta class of A, and now what? And it's after B was generated, so B has the default meta class. I changed the default from A here. I never made any new A here. And that is because the default meta class implementation got added the logic that if it doesn't find a method, it asks its support class, its support default meta class if the method has been added there. An extension made to support Grace, but it's if you try to really understand why this works, I think it's no good idea that this has been done in this way. It's just surprising behavior. And this version here, by the way, does not work, which is I try to add an overloaded method. We have seen, okay, the missing method works, overriding does not work. And I tried it in the same manner as before, but it does not work. It's ignoring my overloaded method. And you know, Groovy has multi-methods. Multi-methods, we say instance-based multi-methods, because if you have a subclass that adds a method, this method can become visible in the superclass. And that's, so it's instance-based and not from some totally unrelated class. But we never intended to have private methods become visible in the superclass. Now here you have an example of that. And I actually know why this happens, but because the algorithm that does multi-methods just doesn't check if it's private. Totally ignores private. Not that Groovy is famous for ignoring private, isn't it? But you know, Groovy does not always ignore private. So a typical example, you have a field that is private, and you want to access it from your closure. That works, no problem. You create a subclass of the class which contains that all, and call the closure again. It does not work anymore. Suddenly the private field is not accessible anymore. Yeah, the problem is we have those helper methods for the MOP like getProperty here, and they don't keep information about from where the call was done. So I can do either private becomes public, or it's invisible sometimes. Well, if you make it public always, then you can have the case that you have a private method in the superclass, in a private method in your subclass, and the private method in the subclass overrides the private method in the superclass. You don't want that. Our solution, forbid private, would be working, but I don't think people want that either. Get and set meta class is also a case that causes problems because it's methods that define a property. If you have, for example, a persistence framework that thinks I have to serialize properties, then it sees meta class as property and, well, has a problem because meta class is not serializable, and if it would be serialized, you would have to serialize like 2/3 of the runtime, or I should say 2/3 of the currently existing meta class structures that are in runtime, and you don't want that either. If it's only the field, we can add transient, but you know, then you may have, for example, Spring proxies. They need special logic to identify get meta class, to not override Groovy logic in this case. Didn't we start with something like seamless integration stories? And it doesn't stop with the property story here. For example, I have here some class, more or less, which is a filter. This example is more or less from Stack Overflow. I didn't think this of. It's an actual problem for someone, or was. I don't know what he did. Maybe he stopped using Groovy, or I don't know, because there's no workaround for this problem. The problem is that this class has a get and set property method already. And it's exactly of the signature that Groovy would use. So what happens here in my X class, I have a property foo, and if I want to access the property, for example, new X and then foo, and I want to set it with bar here, it doesn't work. Because it doesn't set the property according to Groovy logic. It uses the set property method from the filter and does whatever. And well, reading the property has of course the same problem. There's a workaround for that, of course, in the sense that you can use the add symbol to directly access the field. But in case you added some getters and setters there, well, then you can use, of course, the methods, but that's not that what you want to do. You want this to just work, and it doesn't. For invoke methods, I don't know any conflicts like that. But there's a concept problem with invoke method, and it's often used from Java APIs, for example, to invoke methods on the Groovy object, which makes it nicely short. Problem only is that if you use metaclass implementation, then invoke method is used as like last resort to find something for some value for your method. Of course, if you use expandable metaclass, it's not the last resort, it's kind of the first resort. And if you use Groovy interceptable, it's kind of the same. So you see, it's a mess. It's not clearly used only in very specified situations. If you use it with metaclass implementation, you have it first and then later again maybe. So it could call itself and things like that. With special logic to avoid those cases. But the concepts are conflicting here. EMC, well, in general, method missing was added. So invoke method as last resort is kind of absolutely surplus. But people depend on it. We have our unspecified behavior from before, well, or not strongly enforced, I should say, in this case. So some people depend on this one being called as last resort, while others depend on method missing being called, and if you use both, well, only one is used, I think, as last resort anymore. So what do we make better? Of course, we improve the car, make a more nice car, maybe get a new horse with a different color. No, we don't do that. We want to replace the horse. We want to have a real motor that can pull our new fancy car. But we have to fix a few problems too. The problem is we cannot just go and fix them. They're so intervened with the internals that if you fix them, but I mentioned that already, you break the code of people. So over the years, collecting a lot of information and experience with the current system and new developments on the JVM, we have learned some lessons. For example, with the upcoming invoke dynamic, we found out, well, invoke dynamic actually is much better suitable for Groovy than for dynamic languages than our old idea of invoking methods through the meta class, which we gave up in 1.6 already by our custom call-side caching anyway. So already back then we knew that's not the future. But now with Java 7 and invoke dynamic, and Java 8 of course, it doesn't go away so fast, we have support for this kind of logic, and we don't have to do so much ourselves anymore, and it's much faster than what we can do. But the meta-class system is in the way very often. So we can, of course, use that to do our call, but it's not going to be any faster because we have to go the very, very slow path, the very long path through the meta-class, and cannot just cache the call as you would want to do it to get it fast. So we decide, since this is better than our custom call-side caching anyway, to throw away all of our old custom call-side caching code, which will reduce the code base a lot. Believe me, there are many, many classes only related to that, and very highly specialized classes to catch the maximum performance fly. Well, you have to be a fastbird to do that. And the other problem with invoking methods through the meta class is that Hotspot is absolutely not happy about that. I mean, if we resort to reflection, that's okay, that's clear problem for hotspots. But we generate helper classes at runtime to kind of bypass that, and Hotspot is more happy with that. The problem is there's so much code around that Hotspot cannot use inlining or anything to really optimize that. So if you go the long path, it's kept slow, even if you do some back-end optimizations. The obvious solution is, of course, not to use the meta class, but that's not how it was designed. So for the future, we want to change the meta class not from something that invokes our methods and returns the values, and of course same for properties and such, to something that returns something we can use in our caching and call that. So that for the next time, meeting certain conditions, of course, to keep it valid, the next time we can use the cache value instead, and not have to go through the thorny path of steel needles with our bare feet. There are other problems in the meta class, especially if you do many updates of the meta class, or if you use categories and such. You meet the problem that there are synchronization states to be synchronized through logs or through synchronization or volatiles at least. But I can tell you, in my first JVM language summit, I found out that hotspot totally sucks when it meets even a volatile. It stops optimizing totally. It's like a big wall. Oh, I don't go there. No, that's scary. I don't want to go there. And that's even if you don't use any multi-threading at all. The people from SUM always claim you don't have overhead for volatile, and if it's in a single thread case. And you know that's true, but you don't get the optimizations either, so you're always in the most slow interpreted mode. And that's a problem. And typical for most applications with Groovy is they do their changes to the meta class at startup. You don't really need any ability to make a change immediately visible to another thread in most cases. So we will go and make a change there and make the meta class a kind of immutable. And if you want any change, you will have to create a new meta class with the changes. That's currently very modern in concurrent programming styles. The advantage is we can do it totally unsynchronized then internally. If you call a method, there will be no synchronization involved in anymore. And then hotspot has a better chance. There's also, if you ever did look at the bytecode of Groovy class we generate, besides many helper methods we generate, there's also some fields we create, like the meta class field, also 2 timestamp fields. One of them exists only because of historical reasons. It's old code, but you don't know who uses it. And we have the call site array field, which, of course, since we changed to invoke dynamic, we don't have the call site array field because that is used for our call site caching. The timestamps, they are only used to identify recompilation needs. Why do I have that in every class? I don't. Here's the simple answer. So instead of having that by default, we should identify the cases where they are and then give accordingly mechanisms for that. And then hotspot would work without employing Spring Source employees to invent something called Spring Loaded with some special logic only to enable hot swapping for Groovy code. Hopefully. If you ask a JVM engineer how hot swapping, what conditions have to be met that a class is hot swappable, then they try not to look at you and go away. That's a black box. That's mystery. You can only... there are some things you know. If you rename your fields or something, it's breaking. And in this timestamp field, there was the time indicated, the time as value in there. So every time you recompile, it changes. Hot swapping is broken. And then you have cache state in your call site array, which only matters to the state before, not to now, and then, well, it's broken. So you have to be aware of that. One known problem to people using Rails, for example, or in an older version, with a bit a kind of low memory profile, which sooner or later happens, is that Groovy can garbage collect its meta classes, and it's recreating them on use. Of course, only if you didn't modify them. And of course, only if they haven't been assigned to the Groovy field, and only if, so in other words, only if you didn't use a real per instance meta class. But the recreation of those meta classes is expensive and involves locking and involves, for example, the bean introspector from Sun, which uses internal synchronization on classes that might be used by your class loader, and you can get in deadlocks, for example. Not to mention synchronization we have to do internally ourselves to avoid you using the meta class before it's done initializing, for example. The lesson we learned from that, what we learned from that is more or less: one, we have to keep our meta classes as small as possible to lower the memory profile. Two, we will use Java 7 class value instead to keep a still collectible meta class, but only if the class has been collected. Currently we cannot do that. Currently we have a global memory aware concurrent. I mentioned that one already, but it's a different one here. It's a map, and the meta class can keep the class from being collected because the garbage collector not always knows that a weakly referenced meta class that hardly references a class still means the class can be collected. And then it requires a very intensive run of the garbage collector to actually recognize that, and that's not so good. So with class value, this situation will absolutely improve because we will not throw away the meta class anymore, but it's still collectible in case the class is not used anymore. I think that's the right middle ground here for that. Then the other problem is, as you have seen with method missing, we don't need to enforce those MOP methods being present on a Groovy object at all. I mean, why having them? Why having them if we can just look them up dynamically? So maybe we don't implement Groovy object anymore by default. We will see. And of course the lesson of doing too many things for one thing to achieve. I mean, too many ways to achieve the same thing, and well, and then having them slightly different and using them under each other, and but losing information, for example. Well, we have to do a way that is clear and simple to understand for this one. Which is for meta class implementation as an example, because it has 3 invoke methods. Well, actually I think there are 2, and there's a third one, doesn't matter. There's more than one, and they're not, depending on what you use, it's not equal because one has more information than the other, and you cannot just create the information at runtime. So you lose information. And that loss of information leads, for example, to things like the private field being not accessible anymore, or other effects. So to sketch some ideas of what we could do is that, for example, introducing some central class that will handle our dynamic stuff from Java, like adding methods, adding properties, asking for them, invoking methods, invoking properties, all that bundled in one class as interfacing for the Java world. instead of going, for example, through Groovy object. It's a bit less convenient, but much more clear. And of course, you want that to use then this new interface to register instance methods, for example, not going through the meta class and then calling a method that was not always existing. From Java, you have especially the problem that you have to use a closure, and then most probably with a null owner, because the owner is not used here at all, just the surplus information. Well, why not just use any class there? We can reflectively investigate what methods have been declared and then just use that. That is, I think, for Java, much more convenient. In this special version here, you cannot use lambdas because you need an interface for that, and the interface defines the 2 minutes defines the structure we use, and that's not there. And there are problems with limiting changes to the meta class. You cannot prevent the meta class from being changed. You may want that, or you want to isolate your library from meta class changes. You cannot do that. We thought of a concept called realms, which I cannot explain anymore because of the time limit. But I can explain it to you later. It's for isolating meta class changes from each other, so you can be more sure about what happens in your application. Well, then, it's not so much information. I would have a real prototype to play with or something, or some very, very concrete stuff, but I can really only summarize what we have learned so far. It's not so much, but what I can say is you can expect bigger changes. And we try to make it somehow, some way to be able to use older code, but we cannot guarantee that. And I hope you will forgive us, and I hope you will help us making this a very good experience for the future to use those new things. Thank you very much. I should have looked more in this direction. I didn't